So we said that all the atoms of an element have the same number of protons. That's what identifies them as belonging to that element. The number of electrons we saw can change. They can form positive and negative ions. The protons stay the same. What about the neutrons? The neutrons can also be a little bit different. They can vary from atom to atom. And so we have a special word for that, and we call those isotopes. Isotopes are atoms of the same element, but they have different numbers of neutrons. Numbers of protons are the same, the number of neutrons are different. And each element has its own unique natural abundance of its different isotopes. Many of the elements have multiple isotopes, and they're not evenly distributed. If there's 2 isotopes, that doesn't mean that half of them are this way and half of them are that way. There might be, most of them have, 7 neutrons, and a few of them have 6 neutrons. And that abundance, that distribution is different for each element. Here's an example looking at neon. So they're showing you a picture of a neon sign. There are 3 naturally occurring isotopes of neon: neon 20, neon 21, and neon 22. And if we look at this illustration over here, we see that most of the neon atoms, 90.48% of them, are neon 20. That has, 10, right? 10, neon 20, yeah, 10 neutrons. There's a few of them that are the neon 22 that have 12, and there's very few in between with 11. Why? There's no good answer, no easy answer I can give you, because it's just how they are. We have symbols to represent the different isotopes. Most of the time, especially in general chemistry, we really don't care if the 2 carbon atoms we're dealing with are different isotopes or not. But sometimes we do care, and when we do care, we have to have a shorthand way of indicating that. And so we have symbols. So the symbol for an isotope is given this way. Here, X is going to be the element symbol for that element. A is going to be the mass number, and Z is going to be the atomic number. The atomic number is what we talked about previously. It's the number of protons. The mass number is the number of particles that have significant mass. It's the protons plus the neutrons. I don't think they ever show you that in these slides, so I'll write it in here. So the mass, you can't read my mind. The mass number equals the number of protons plus the number of neutrons. So we look at this example here, neon, we call this neon 20. All neon atoms have 10 protons. This one has a total of 20 particles with mass. 10 of them are protons, and the other 10 are neutrons. So what we can do is, it's like they stacked them up so that we could subtract. And that gives us the number of neutrons. As for why the atomic number is Z and the mass number is A, I can't tell you that one. If it was up to me, I'd make A the atomic mass number. Wouldn't that make more sense? A, atomic mass number, and make Z the other one. But no. The mass number, though, is on top. The bigger number's on top. The smaller number's on bottom. And you could think of, well, they did that on purpose so that I could subtract easily. No, they didn't, but if it helps you remember. So here, 21 minus 10, this one has 11 neutrons. And over here, 22 minus 10, this one has 12 neutrons. So the number of neutrons is not specifically given in the symbol, but we can find it out just by doing a real simple subtraction. So those are symbols for the isotopes. The mass number is the sum of the protons and the neutrons. and the number of neutrons is the difference between the mass number and the atomic number. I just showed you that. So another way to indicate isotopes is to use the element, either the element symbol like Ne here, or the element's name followed by the mass number. So Ne20 means neon that has a mass number of 20. Or we could say neon 20. And so if I say, potassium, better make up something that could actually exist. I say, well, potassium 30. Well, that's potassium that has a mass number of 30. In that notation, the atomic number isn't given, but we can look up the atomic number very easily on the periodic table. So here's another example. We want to find the atomic number, the mass number, and the symbols for the chlorine isotope that has 18 neutrons. Okay, so chlorine, the symbol for chlorine is what? Cl, capital C, lowercase l. I don't know if you've noticed, is that a 1, a capital I, or a lowercase l that I just drew? Whatever you say, I can say it's one of the others. It's not obvious, is it? Okay, so try to be careful when you write. So I make my capital I's like that, my lowercase l's like this, and the number 1, if there's any question, I'll make it like that. Sometimes I'll make my 1's like this. But try to make them look different. Okay, so you'll see I always use a script L for my lowercase l's, just because it can get confusing. Chlorine. Okay, so we're told that we have 18 neutrons. How many protons does chlorine have? 17 protons. So we have to add 17 and 18 to get the mass number. So that's what, 35? The mass number is A, because that doesn't make sense. The mass number goes up here. The number of protons goes down here. So that is one of the symbols for this chlorine isotope that has 18 neutrons. Here's the atomic number the atomic number is 17. That's Z. Z is 17. The mass number is 35. Other symbols for this would be Cl-35, or write out the name of chlorine, chlorine 35. So you should recognize those 3 different ways of representing isotopes. How many protons and neutrons are in the potassium isotope K with a 39/19? Well, what does that 39 mean?
That's the protons plus the neutrons.
That's the protons plus the neutrons. That's the mass number, right? And 19 is the atomic number, the number of protons. If we subtract those, we get 20, and what's that?
The number of neutrons.
That's the number of neutrons. So this one has 20 neutrons. The atomic number equals the number of protons. So, if you're faced with a question like that, you've got your periodic table. Find K on here, and this 19, and maybe you've forgotten what the 39 and the 19 mean. Maybe you think, oh, maybe 19 is the number of neutrons. Well, look over here, K and 19, hopefully you remember that the number of protons is what's on the periodic table. That's the protons. That other one's bigger. That must be both of them together. So some of these things you can kind of puzzle out, even if you don't remember them just quick.